Okay guys, welcome back. So let us proceed with the last example, which is this one. Find the general solution for this differential equation. Okay, so now the given differential equation to you is y double prime minus 2y prime minus 8y is equals to cos 2x plus 5 sine 2x. Okay. So the first step is get your YH again by assuming fx is equals to 0. So you will have y double prime minus 2y prime minus 8y is equals to 0. So change this one into characteristic equation will give you m squared minus 2m minus 8 is equals to 0. So therefore your m is equals to 4, your m1 is equals to 4 and your m2 is equals to negative 2. Okay, so this is case 1, different root. Okay, so what is the general solution? So your YH is equals to AE for x plus BE negative 2x. It's okay if you let your m1 is equals to negative 2, your m2 is equals to 4. Okay, doesn't matter. But stick with your m, okay, that you already choose. So since I'm choosing m1 is equals to 4, m2 equals to negative 2, that's why I have AE for x plus BE negative 2x. Okay, so clear? So this is your YH. So the next one, you're going to find your YP. So what is your fx here? Function on your right hand side is this one. Okay, so this is a trigonometric function, so you know that this is case 3 UC. Okay, so therefore your fx is equals to cos 2x plus 5 sine 2x. So what is the value of alpha here? Your alpha is equals to 2. This one. Don't worry, you will have the same value for alpha. Okay, since this is case 3. So your alpha is equals to 2. So what is suggestion for your YP? So your suggestion for your YP will be C cos 2x plus D sine 2x. Okay, so next we are going to test either you can use this YP or not, so you have to compare. So again compare YH and YP. So your YH is equals to AE for x plus BE negative 2x, and your YP is equals to C cos 2x plus D sine 2x. Clearly you can see that there is no similar function of terms in YH and YP, isn't it? So YH is not equals to YP. So therefore you can choose this one as your YP. This example is much more easier compared to the first one that we already discussed in the previous video. So I hope you can do it. So next, what you need to do is you have to differentiate your YP. Okay, and substitute back into your differential equation, compare with your right hand side and get the value of C and D. So I'm using this one. So our YP is equals to C cos 2x plus D sine 2x. So differentiate the first one, y prime will give you negative 2c sine 2x plus 2d cos 2x, and y double prime is equals to, differentiate sign will give you cos, so you will have negative 4c cos 2x. Differentiate cos will give you negative sign, so you will have negative 4d sine 2x. Okay, this one you don't need any product rule or any differential technique, just differentiate this one directly. Okay, so I'm doing. So now you have your y prime and y double prime, so substitute back into your differential equation. So therefore you will have y double prime minus 2y prime minus 8y is equals to cos 2x plus 5. Cos 2x plus 5 sine 2x. Okay. So what is your y double prime? So you will have negative 4c cos 2x minus 4d sine 2x. So this is your y double prime. Minus 2, so what is your y prime? Negative 2c sine 2x plus 2d cos 2x minus 8, what is your y? C cos 2x plus d sine 2x, which is equals to function on your right hand side, cos 2x plus 5 sine 2x. So expand and simplify what you have on your left hand side. So you will have negative 4c cos 2x minus 4d sine 2x. So minus minus will give you plus 4c sine 2x minus plus, so you will have minus 4d cos 2x minus 8c cos 2x minus 8d sine 2x, which is equals to cos 2x plus 5 sine 2x. So simplify this one. So with cos coefficient, we start with cos 2x. Okay, so you have this one, you have this one, and also this one. Okay, so negative 4c minus 8c will give you negative 12c. So therefore, you will have negative 4d minus 12c cos 2x. Another one is for the sine function. So this is sine 2x, this is sine 2x, and also this one. So you will have plus 4c minus 12d sine 2x, which is equals to cos 2x plus 5 sine 2x. Okay, before that, as you can see here, I'm writing D in front and C at the back, but for this one I'm writing C in front and D at the back. So actually you can use either way around lah. Okay, but before we can compare, you have to rewrite this again. Okay, so let's choose this one. Okay, the first one here, I rewrite it as negative 12c minus 4d. Okay, cos 2x plus 4c minus 12d sin 2x, which is equals to cos 2x plus 5 sin 2x. So we are using this one, not this one. Okay, so compare left hand side with the right hand side. So cos coefficient of cos 2x, so on your left hand side you have negative 12c minus 4d, which is equals to 1. Why 1? Because this one. This is cos 2x, this is cos 2x. So the coefficient of cos is 1. Okay? So the second equation, so this is your first equation. So the second equation is by comparing the coefficient for sin 2x. So you will have 4c minus 12d is equals to 5. Okay, so this is second equation. So that's why I rewrite this again as this one. Okay, so that I'm having these two equations. So the first term is a constant c and the second term is a constant d. Okay, to make sure that the equal constant. Okay, you can write it as negative 12, sorry, d here, c here, but when you substitute into your calculator to get the value of c and d, it might be confusing. Okay, so that's why I rewrite it again as this one. Okay, so you can either use substitution method or elimination method, or just use your calculator to get the value of c and d. So find equation. So now you involve with unknown. So you have two unknowns, c and d. So what is your a1? This one a1, b1 and c1. This is a2, b2 and c2. So substitute this value will give you, so negative 12, negative 4 and 1, and another one is 4, negative 12 and 5. So therefore, so the first value, the calculator will give you x and y. So what is x? So x will refer to the first constant, which is c, and y refer for second constant, which is d. Okay, so therefore you will have your c is equals to 1 over 20 and your d is equals to negative 2 over 5. Okay, so now you have the value of c and d. So substitute into your yp. So therefore your yp is equals to, okay, c cos 2x plus d sin 2x. So c is equals to 1 over 20. So you will have 1 over 20 cos 2x minus 2 over 5 sin 2x. Okay, so now this is your yp. So you have your yh here and also yp, so you can find the general solution. Okay, so the last part will be y is equals to yh plus yp. So your y is equals to ae for x plus be negative 2x plus 1 over 20 cos 2x minus 2 over 5 sin 2x. Okay, so this is the final answer. So I already covered case 1, case 2, case 3 for method of undetermined coefficient. So in my next video, our next lesson will be on how to find YP here by using the second method, which is variation of parameter. Okay, so please try to do this exercise 3.7 on page 98 for case 3, and I will also upload this exercise in that module. So this one, uh, combination of case 1, case 2, case 3, UC, okay, method of undetermined coefficient. By now you should be able to solve this kind of problem by using UC. Okay, so see you guys in my next video. Okay, and in my next video we'll proceed with the second method on finding YP, which is methods of variation of parameter. So if you have any problem regarding my video, please leave your comments in that module, or you can direct WhatsApp me and ask me. Okay, so see you guys. Thank you. Assalamualaikum. Bye.